Hello. So hello everybody. How are you? I hope all of you are well and doing good. So I hope my voice is clear. Yes, my voice is clear, my dear student. Yes or no? Good evening to you all. Good evening. Good evening. Good evening. Okay. Okay. So let's start today's session. Right. So today is our lecture number 3. Today is our lecture number 3. Lecture number 3, right? Of theory of metal cutting. And in this lecture, we are going to cover geometry of single point turning tool, ASA and ORS system, and I will try to cover shear angle also, right? So let's start. Look, geometry of single point cutting tool. As you can see, this tool is what? Can anybody guess? Can anybody guess? What is this tool? Can anybody guess the name of this tool? Name Manish Kumar, Jayesh Patel, Jayesh Patil. Nobody is going to guess the name. So what is the name of this tool you are seeing on your screen? Yes. What is the name of this tool which you are seeing on your screen? Isn't it the turning tool? Isn't it the turning tool? Yes or no? So, my dear, is it what? It is a turning tool, right? It is what? It is a turning, right? Is turning, right? This is turning tool, right? The turning. So, please see, this is a turning tool. This is a shank. This is what? This is what? This is a shank. Going to fix into the tool pole. This shank which is going to the right, either you're talking this or either you are talking this. The thing is that is what this shank is going to put into here. You can see the marking. This is the basically you are fixing this tool into the tool post. Okay, so the marking that you are fixing the tool in the tool post. You are fixing the tool into the tool. Shank is going to fix into the tool. Now my dear, here please see this, or if this, both the edges are same. This edge is known as what? This edge is known as side cutting. This edge is known as what? This edge is as right. This edge is side cutting, side cutting edge. A principal cutting edge with the cutting, right? This edge is known as what? Side cutting, right? Now, please see the another edge. The another edge. I'm talking about this edge, right? I'm talking about this edge, or I'm talking about this edge, right? So here I'm talking about this edge. Please here, here. This is what? End cutting edge. End cutting edge, right? This what? Is it clear? This is what? End cutting. Now, my dear, as you know, this is a side cutting edge, right? Okay. So, is these edges are clear to you? Now, where you are keeping this tool now? Where you are keeping this tool? This is base of the tool, base of the tool, right? Base of the tool, where you are keeping, that is a base. Okay. The next thing is that this is what? This is the width of the tool, right? This is what? This is width of the tool. That is what? W, right? That is width of the tool, width, right? Width of the tool. Now, my dear, if you are talking about this thing, right? This is the length of the tool. You are talking about this, this, the length of the tool. What is length of the what? This is the length of the tool, right? What is length of the, right? This is what? Length of the, this this is basically a length of the tool, right? So this is what? This is the length of the tool. This is length of the tool. Length of the, this is length of tool. Now tell me, is that point is clear? Shank, side cutting edge, end cutting edge, and base of the tool, width of the tool, and length of the tool. Is this geometry is clear to you, my dear? Parth Shukla, Manish Kumar, no name. Okay, okay. So this name, this a little bit geometry is clear to you. Now, my dear, as you know, this is what? This is the principal or main cutting edge, right? This is the principal or main cutting edge. This is the principal or main cutting edge. Generally, this cutting edge, right? So basically, this cutting edge will do the cutting, right? This cutting edge will do what? Will do the cutting, right? Will do the cutting. Just a minute. Just a minute. Just a minute. Just a minute. Continue. So I hope my voice is clear. Yes. So what I was saying, basically, this is the side cutting edge, right? This is a cutting edge which will do what? Which will do the cutting. My dear, when this cutting edge will do the cutting, from where the chip will flow? On some face, na? So my dear, when this edge will do the cutting, so the chip will flow like this. Yes or no? The chip will flow like this. Tell me yes or no? The chip will flow like this. Good. So here the chip will flow like this. Yes or no? Now tell me when the surface on which the chip is flowing, that surface is known as what? Bake surface. So you have seen that here the chip will flow, right? Here the chip will flow, right? Here the chip will flow, and this cutting edge will do a cutting. So here the chip will flow. Yeah, here the chip will flow. Please see. So on that surface, the chip will flow. This is chip. This is what? This chip, right? This is what? This is chip. So that surface is known as what? That surface is known as what? My dear, that surface is known as rake face, right? Rake surface. rake surface. So this surface, okay, this surface, this surface, this surface, or I'm talking about this surface of the tool, right? I'm talking about this surface of the tool is known as what? Rake surface. Rake surface. Tell me, is that surface is clear to you? Is that surface is clear to you? Yes or no? Is that surface is clear to you? Very good, no name. That surface is known as rake surface. Now, the surface which is below the side cutting edge, now the surface which is below the side cutting edge, as you can see in the figure, as you can see in the figure, the surface which is below the side cutting edge like this. I'm talking about this, my dear. I'm talking about this, right? And I'm talking about this. This surface is known as what? The surface which is below the side cutting edge. That surface is known as your side flank. So this is what, my dear? This is what? This is a side flank. Is that point is clear? So this is what? This is side flank. Now the surface which is below the now the surface which is below the end cutting edge. Now the surface which is below the end cutting edge, right? The surface below the end cutting edge is known as end flank. Is known as end flank. Now tell me, side flank, end flank, and rake surface is clear to everybody. Now tell me, side flank, end flank, or rake surface is clear to everybody. Yes, side flank, end flank, side flank, end flank, and rake surface is clear. Is clear. Okay. So these are the surfaces, right? These are the surfaces. Now we are doing to understand the angles, right? Now we are doing to understand the angle. The tool geometry of a single point turning tool is going to be understand by, okay, now I'm going to explain the angle, right? Here, the tool geometry of single point turning tool. Here I'm going to write that which tool I'm talking about. Geometry of single point turning tool, turning tool. I'm going to understand the geometry of single point turning tool in free plane. I'm talking about basically angles. Geometry in terms of what? Angles. The angles, the different surfaces are going to be what? Made. So here I'm going to explain geometry of single point turning tool. Geometry of single point of single point, right? Turning tool, geometry of single point turning tool. Okay, in geometry of single point turning tool, that is, I'm talking about the angles. Angles. Okay, according to according to according to ASS, according to ASA system, American Standard Association system. Okay, according to ASA, my dear, according to ASA system, basically, please try to understand this point which I'm explaining here, according to ASA system, right? According to ASA system, basically the angles of a turning tool which we are trying to understand in a plane which are mutually perpendicular. Okay, ASA system, basically there will be a three planes, right? There will be a three planes which are basically what? Which are perpendicular to each other, right? Try to understand this point very carefully. Look, this is a plane, this is a plane, this is a plane, this is the first plane, okay, in which we are trying to understand the angles. There is another plane, there is another plane, okay, this is the another plane, this is the another plane, we see this is the another plane. Now you can see that this plane is what? This plane is perpendicular to what? This plane is perpendicular to this plane. Yes or no? Tell me yes or no. This is the base. Or let me draw this plane in a different manner. Basically, I have to draw this plane. Try to understand. I'm talking about I'm talking I'm talking about this plane, right? I'm talking about this. Okay, just leave it. Try to understand the angles, right? The first plane which I'm drawing here, a plane perpendicular to base, perpendicular to base, perpendicular to base, and perpendicular to base C. This is a plane. Are you able to see? This plane is what? This plane basically, as you can see, this plane basically perpendicular to base. This plane is what? Perpendicular to base, right? And along the length along the length of the tool, length of the tool, right? Length of the tool. Here you can see the plane which I have drawn. I'm talking about this plane. Tell me, this plane is perpendicular to the base of the tool and along the length of the tool, yes or no? Right. Now in this plane, basically what you have to do, you have to take the projection, right? You have to take the projection. You have to take the projection. Let me draw the projection here. You have to take the projection like this, right? You have to take the projection like this. Please see, you have to take the projection like this. You have to take the projection like this. See, you have to take the projection like this. Are you getting my point? You have to cut the tool in this plane. When you are going to cut the tool in this plane, right? Now again see, you have to draw the plane, a plane which is what? Along the length, right? This is a plane which is what? You can see, this is a plane, my dear. You can see here. Okay, I'm talking about this plane. I'm talking about this plane. Okay, I'm talking about this plane, right? I'm talking about this plane. I'm talking about this plane. I'm talking about this plane. You see here, please try to understand this plane which I have drawn here. Please see. Please see the plane. Look, please see the plane. This is a plane, right? This is a plane, right? And this is the plane. And here, this is the plane. Is that plane is clear? Tell me, everybody. I hope this plane is crystal clear to everybody, right? Now in this plane, you have to take the projection. Okay, you have to take the projection in this plane, right? Like this, right? Like this. You have to take the projection like this. See here. You have to take the projection of the tool in this plane. See here. See here. Here, my dear. Yes. See. Yes. Okay. The projection of the tool. Are you getting my thing? Yes or no? Tell me. Is that projection is clear? Now, in this plane, take the inclination, of the rake surface, okay, in this plane, take the inclination of rake surface in this plane. Is that clear? The inclination of rake surface in this plane is known as alpha b. That is nothing. It is a alpha b. That is nothing. It is a alpha b. Alpha b is nothing. It is the back rake angle. It is a back rake angle. It is a back rake angle. It is a back rake angle. Yes or no? It is a back rake angle. Is that clear? Is that angle is clear? Back rake angle is clear to everybody? Tell me, back rake angle is clear to everybody? Yes or no? Are Baba, tell me, back rake angle is clear to everybody? Now, in the same plane, see the inclination of, this is the end flank, right? This is what? This is basically a part of what? Part of end flank. This is end flank. Now see the end flank inclination. Now see the end flank inclination in this plane. The end flank inclination in this plane is your end relief angle. Your end relief angle, right? Your end relief angle. End relief angle and clearance angle. Sometimes we call as what? Clearance angle and relief angle. Is these two angle are clear to you? Is these clear? Is these two angles are clear to you? Now, if I'm going to draw the similar, basically, generally, you want these plane like this. This is a plane, right? This is a plane, and this plane, basically, you have seen that the projection. You have seen that the projection is like that in this plane. See, in this plane, right? In this plane, see. So generally, you will see the projection like that, right? This is the tool. So whenever you see the inclination of the rake surface, the inclination of the rake surface, right? The inclination of the rake surface in this plane, it is known as back rake angle. The inclination of end flank, it is known as what? It is end relief angle. I hope these two angles are crystal clear to you. Now let's move to the another plane, right? Now let's move to the another plane, my dear. Now you have to take a plane. Now you have to take a plane, right? Plane perpendicular, perpendicular, plane perpendicular, right? Plane perpendicular, plane perpendicular, okay, plane perpendicular to base, in perpendicular to base and perpendicular to base and parallel to width of the tool, width of the, see, which basically you have seen that, you have seen that this is what this is the, this is what width of the tool, right? This is what width of the tool. So as you can see, this plane I'm talking, right? This plane I am talking, my dear, I'm talking about this plane. This plane, please see, I'm talking about this plane. This plane, I'm talking about this, I'm talking about, yes. Are you getting this point? Are you getting this point? I'm talking about this, right? I'm talking about this plane. Yes, is this plane is clear? So this is a plane basically. Which plane is that? Your A, B, and D. This is the plane. Now in this plane, see the inclination. Now in this plane, the inclination of the rake surface. In this plane, see the inclination of the rake surface. Okay, see the inclination of the rake surface in, this is known as side rake angle. In this plane, see the inclination of the side flank. In this plane, see the inclination of the side flank. It is known as your side relief angle. It is known as your side relief angle, right? See this inclination. So this angle is known as side relief angle, right? So this angle is known as side rake angle. So I hope these two angles are clear to you. So here, this is what, this is side rake angle, and this is what your side relief. Let me write down here. Let me write down this angle. This side rake angle, right? This is side relief. What side relief? So this is side rake angle. Side rake angle is side relief. Side relief. So I hope now you understand these two angles. So basically, if you draw this projection will be look like this. See, this projection will be look like this. See, this is the projection. This plane is what? Perpendicular to what? This plane is perpendicular to this plane. This plane is what? Perpendicular to base and parallel to width of the two. Parallel to width of the two. Right? So see, you have seen this projection. Please see, you have seen this projection. Yes or no? You have seen this projection. Please see, you have seen this projection. If you are going to see, basically in this plane, this type of projection you are going to see. Am I clear? Yes or no? Tell me. So this type of projection you are going to see in this plane. So I have drawn a similar projection here. So my dear, this is what your side rake angle, and this is what your side relief. So how many angles you understood? Back rake angle, end relief angle, side rake angle, side relief angle. So four angles you understood. Now the two more angles are when you see the tool in a plane, when you see the tool in a plane parallel to base and along the length of the tool. Now see the tool, right? Plane here, the plane is here, the plane is, see here, the plane is parallel to base, parallel to base, plane is parallel to base, right? Parallel to base and along the length, along the length, along the length of the, along the length of the two. So this is the plane, my dear, which I'm talking about, a plane, right? A plane which is, see here, here, which I'm talking about, see a plane which is parallel to, right? Parallel to base and along the length. This plane is what? If you properly, I'm talking about basically this. I'm talking about this plane. This is a plane which is parallel to the base and along the length of the tube. Now see here. Now see here. Now see the side cutting edge. Right? Now see the side cutting edge. Okay. And this is end cutting edge. This is end cutting, right? And this is the nose. Now, my dear, you have seen that this is what? The end cutting edge, and this is what? This side cutting, right? So let me write down, this is end cutting, right? End cut, end cutting, right? End cutting edge, end cutting edge, end cutting edge, right? And this is what? Side cutting, what? Side cutting, right? Side cutting. Now see properly. In this plane, you have to see the inclination of side cutting edge from this plane. You have to see the inclination of side cutting edge from this plane, known as side cutting edge angle. In this plane, you have to see the inclination of the inclination of end cutting edge Okay, this is known as end cutting edge. As end cutting edge. So I'm going to write here that CS is what? CS is side cutting, edge angle, side cutting edge, side cutting edge angle, right? Side cutting edge angle. And your C is end cutting, end cutting edge angle, right? End cutting edge angle. What? This is the side cutting edge angle and end cutting edge, right? End cutting edge. Now tell me, is these angles are clear to you? Now tell me, is these angles are clear to you? Yes or no? Tell me. Yes or no? Tell me. Yes, tell me everybody. Is these angles are clear to you? Yes. Is these angles are clear to you? Okay, is angles are clear to you? Now there will be a nose, basically this curvature, or if I will write, this is what basically, let me write down it another slide, another copy of this slide. Okay, the another copy, right? See here, see properly. Now see here, see, my dear, I'm talking about this. Here you can see this is a curvature, right? This is a curvature, right? This is a curvature. So this is called as what? Nose rate, called as called as right, called as, I mean sorry, nose, simply called as nose of the. Now if this is a nose, then the curvature will be, okay, I'm talking about this curvature. So this curvature is basically is what? Rn, and Rn is nothing, is a nose is, I hope this thing is crystal clear. Rn is what? The nose. Yes, I hope the nose radius is clear. The angles are clear. Okay, the angles are clear. Now let's move in this slide. I'm going to make the overall, okay, summary. Basically, this was the plane. You have seen plane. You have seen that. Have seen that. This look like this. This is side cutting edge. The top view. Have seen the top view, right? In this plane, have seen the top view. Have seen the top view. Now here, this, right? This. So this is what? Side cutting edge. This is what? End cutting. Sorry, this is the end cutting. End cutting. So just a minute. Let me do a correction. Let me make a correction here. Let me make a correction. Let me make a correction. Yes, this is the end cutting. So this is the end cutting. I hope now you understand this thing. Now you understand this summary. Have seen, my dear. These planes, these plane, this is the plane number one. This is what? The plane number one, the plane number one, the plane number two, and this is the plane number. All the three planes are mutually perpendicular. Okay, one plane, plane one and three. Right, plane one, two, and three. Plane one and three. Plane, plane one, two, and are actually perpendicular, perpendicular to each. Mutually perpendicular to, planes are mutually perpendicular. When you see people in a plane which are mutually perpendicular to each other, okay, this system is known as ASA, right? ASA. The advantage of ASA system is that, okay, the advantage of ASA system is that to understand, the understanding of angles and measurement of angles are easy, right? The advantage, the advantage of ASA system. Why we use the ASA system? Sometime question, sometimes student ask the question, sir, why we are using ASA system? Advantage of ASA system is that to understand and measurement of angles are easy. To understand and measurement and measurement of and measurement of angles are easy. Measurement of angles are right. But what is the disadvantage? My dear, the disadvantage of this angle are, the disadvantage of this angle is, the disadvantage of the angle is analysis of machining will be difficult, right? The analysis of machining will be, the disadvantage of disadvantage of ASA. So what is the disadvantage of ASA system? The disadvantage of ASA system is analysis of machine difficult, right? Analysis of machine will be difficult, will be difficult. This is a problem, right? This is the problem. I hope you understand. This is the thing, right? Now what we do, the meaning of analysis is, the meaning analysis is force and power calculation, right? Calculation, force and power calculation become what, right? Force and power calculation become, okay. That's why to overcome this, we use, to overcome this we use forest system. To overcome this we use forest system. To overcome this disadvantage, overcome this disadvantage, this disadvantage, this disadvantage, we use, we use ORS system. ORS, orthogonal rake system. ORS. ORS stands for orthogonal rake system. ORS stand for orthogonal, right? Orthogonal rake, right? ORS stand for orthogonal rake. Yeah. So this is the major thing. So my dear, according to ASA, let me arrange this, right? According to, let me arrange this angle. According to ASA, Just a minute. So please see here the ORAS system and ORS system I'm writing here. Okay. So ASA, American Standard Association. Okay, system. In this system, basically what we do, we write here, we write here back rake angle first, then side rake angle, then end relief angle, then side relief angle, then end cutting edge, then side cutting edge, then we end with this. Yes, will be in inch, right? Will be in inch. If you go to the ORS system, if you go the ORS system, right? Write down here the ORS system, right? So here will be the ORS system, orthogonal rake. In this ORS system, basically we are going to write, okay, in this ORS system, we are going to write what? Let me write down here. I will come. I, the meaning of I is inclination. Okay, of the same tool, of the same turning tool, we are going to convert same turning angles of the turning to ORSs. So here I stand for alpha stand for orthogonal rake angle, which is of the turning tool, right? Which is of the turning tool, which is of the turning tool. At the next place, side relief angle will become, right? At the next place, side relief angle will be the next place, end relief angle will be. Basically, we are measuring in different planes. So let me write down here. Here, side relief angle. Okay, and this is what, let's say, this is the end relief, and the next is your end cutting edge. This one, lambda, that is your approach angle, and principal cutting edge angle. And we are going to end with as R in, right, in M. So let me write down. I is what? I is the angle, incline angle. Okay, you know the following meaning of this thing, this representation. So here I'm only going to write the ORS system. I stand for incline, alpha stand for orthogonal, ortho rake angle, ortho rake angle, my dear, right? And this is stand for side, side, right, side, and this is end, right, end relief and right. This is stand for end cutting edge, end cutting edge, end cutting edge, right, end edge, and this is lambda, that is for principal cutting edge angle, principal, principal, right, principal end cutting angle, sorry, principal cutting edge angle, right, principal cutting edge angle, principal cut edge angle, principal cutting edge angle, or sometime we called as approach or approach, approach. And basically what is that? Lambda is equal to degree. Let me show the figure. In this figure you can understand, please. This is what? This is the basically 90-degree in between them, right? What? Lambda 90-degree minus principal and cutting edge, principal cutting edge, right? These are the present. R stand for no, but it will be mm, right? But it will be, my dear, for orthogonal cutting. Always remember, that for orthogonal cutting, somebody say orthogonal cutting, orthogonal cutting. If somebody say orthogonal cutting, then your I equal to what? I equal to what? 0, right? I equal to what? 0. Or if somebody says, chip flows in orthogonal plane, chip flows in orthogonal plane, orthogonal plane. The meaning is still same. The meaning is still same, my dear. The meaning is what? Still same. The meaning is still same. Either you say orthogonal cutting or you say the chip flows in orthogonal plane. The meaning is still same. The meaning is simple. Here the meaning is still remains same. That I equal to what? That I equal to what? 0. That I equal to what? Yes. Is it clear? Yes. Is it clear? So I hope this point is crystal clear. ASA and ORS system. Is it clear? Now there is an interconversion between ASA and ORS system. So let me write down interconversion, interconversion between interconversion, okay, interconversion between, okay, interconversion between ASA and ORS system, right? Interconversion between interconversion ASA and ORS system. Interconversion, interconversion between ASA and ORS system. Basically, you have to, yes, sir, this series is difficult, sufficient for universal exam. You can't say the great Hazik Imam can't say that this series was for universal exam, but I assure you this series is sufficient for gate, right? I assure you this is sufficient for your. So interconversion between AS and ORS. My dear, how can we convert? I mean, I can't do the analysis, so I have to convert back rake angle, side rake angle into what? Orthogonal rake angle. How can I convert? So there is an interconversion formula, that is what? Tan of orthogonal rake angle, that is alpha, into tan of side rake angle, that is alpha s, into sine lambda, that is approach angle, plus tan of alpha b, that is back rake angle, into cos of lambda, right? Into cos of lambda. So this is the formula. And clearly here I'm going to write the another formula. I'm going to write the formula, please. Now this is the first formula which you have seen. Now the second formula is that tan of back rake angle, tan of back rake angle equal to tan alpha cos lambda, tan alpha cos lambda plus plus tan I plus tan I lambda. The second formula of the interconversion between ASA and ORS. Next formula is tan of side rake angle, right? Tan of side rake angle equal to tan alpha sin lambda, right? Tan alpha sin lambda minus tan I cos lambda, tan I cos lambda. The another formula is tan I, right? The another formula is tan I. So the tan I equal to what? Minus of tan alpha s cos lambda, right? Plus tan back rake angle in lambda. So my dear, these are the four, okay, interconversion formula which you have to remember. right? Which are very important in your gate, which are very important for your GATE exam. Is that point is clear to everybody? Yes or no? Is that point is clear to everybody? Yes or no, my dear? Is that point is clear to everybody? Yes or tell me. Yes or no? Tell me. Yes, please. Is that point is clear to everybody? Now, here I am going to write a question, right? A question was asked. A question was asked in 8008, right? A question was asked in. Let me write down this question. Write down the complete of this. Let me write down the complete language of this. Right. Okay. Let me write down the complete language of this question. Okay. My dear, in a right. Okay. Let me conduct a poll also. Right. Here I'm going to conduct a poll. So where is the poll? Here I'm going to conduct a poll also. So you will enjoy this. Right. You. Okay, the poll is not working. Okay. Leave it. So let me write down the question. In a single point turning to single point turning, right, in a single point turning tool, side rake angle, side rake angle and orthogonal rake angle and orthogonal rake angle are equal, are equal, right, are equal. Lambda is the principal, lambda is what? Principal cutting edge angle, principal cutting edge, right, right, and its range is, and its range go to 90 degree, 90. The another information is the chip flow, the in orthogonal plane, orthogonal plane, orthogonal, the value of lambda, okay, is closest, is closest to, right, option A, option 2 degree, okay, option B 45 degree, right, option degree, right, and option is 90 degree. Yes, please solve this question. It's a very good question. Please solve this question. Yes, please solve this question. Will you solve this question? I'm waiting. My dear, what are the information? Okay, what are the information? The information, the solution. What is given in the question? Given. The given is basically is that side rake angle and orthogonal, right? and lambda is the principal cutting edge angle whose 2 degree, right? The chip flow in orthogonal plane means I equal to, then you have to tell me the exact value of lambda. My dear, which formula we can apply? I think apply this formula, because in this formula side rake angle, orthogonal angle, and lambda and I are coming, right? So here tan of alpha is tan of alpha sine of lambda minus tan of I cos of lambda. So in this question you have seen that I equal what, and here tan alpha is equal to tan alpha lambda. Alpha is equal to alpha, it will cancel out, sin lambda equal to 1, and according to this range, lambda must be lambda. So this is the final answer. The final answer. It means the correct one. Yes or no? Option D is the correct one. Tell me, is that point is clear? That point is clear? Hello everybody. That point is clear? Is that point is clear? Yes or no? Is that point is clear? Yes. That point is clear to everybody. Now the next concept which we are going to do is your shear angle, right? That is represented by phi, right? That is represented by, here Amit sir is there. So welcome Amit Maurya sir. Welcome Amit Maurya sir. Now let's talk about the shear angle. My dear, this is the machine of an workpiece. The machine, and you have noticed that while doing the machine, the tool, right? Here you can see that this is, and the tool is moved toward the workpiece cutting velocity, and this is a reference line or normal line, right? Here you have seen that this is what, shear plane, and the inclination of shear plane from the horizontal is what, shear angle. Now here you can see the chip is, right, the chip is what, the chip is moving, the chip is, you can see the chip is moving, right? The chip is in the upward direction. Okay. Now, my dear, the thickness before cut is, the thickness before cut is what I'm talking to about this. The thickness before cut is what? T naught. Okay, this is uncut thickness. And if you draw a perpendicular from the top layer of the chip to the bottom layer, then it will be give you what? It will give you, right? It will be T, that is a chip thickness. So here T naught is what? Uncut chip thickness, right? Uncut chip naught is what? Cut chip. And T is what? Chip, chip thickness, right? TC, what? Chip thickness. Now, this is the basically in shear angle, basically there is a R which is called as thickness, chip thickness ratio, right? Chip thickness ratio. R is a chip thickness ratio, or sometime we call a cutting ratio, right? Or you call as cutting, or you call as cutting ratio, right? So basically this chip thickness R equal to what? It not by T, equal to length of the chip equal to length of by uncut equal to the chip velocity divided by the cutting velocity equal to sine phi okay, divide by cos of phi minus alpha. So please remember this analysis. Please remember formula, right? Please remember this formula. And when you are going to simplify r equal to sine phi divided by cos of phi minus alpha, when you are going to break down cos of phi minus alpha like cos of a minus b and simplify the thing, get a formula. You will get a formula that is 10 of phi equal to r cos alpha divided by 1 minus r sine alpha, my dear. Right? My dear, this is a very important formula. Here you can see that phi is the function of what? Phi is the function of chip thickness alpha, chip thickness ratio in alpha, right? So phi depend on the cutting parameter, right? If you the cutting parameter same, if you keep the cutting parameter same, then shear angle will remain same throughout the machining. Okay, so if the cutting parameter, the cutting parameter, the cutting parameter, if the cutting parameter is same throughout the machining, same throughout the machining, throughout the, then phi is, then phi is also same. Phi is phi remains phi is also constant. Phi is not going to change, right? Phi is not going to. Now the thing is, people ask to me, sir, what is the physical significance of chip thickness ratio? This R is what? Thickness ratio. What is the physical significance of this chip thickness ratio, my dear? Basically, it is an index of the amount of plastic deformation. It is an index of amount of plastic deformation which the metal into the chip, which the metal into the chip has, right? It is an index of the, it is, it is, right? It is the index of the amount. It is the index of the amount of the amount. It is the index of the amount of plastic deformation, of plastic deformation, plastic deform okay, of plastic deformation, the metal into the chip, which the metal into the chip, okay, into the chip, which the metal to the to the chip has undergone. Chip has undergone. Chip has undergone. Has undergone. Right. There is one more parameter, that is H. H is nothing that it is 1 by R. This is the inverse of chip ratio. Inverse RSE. Inverse of chip. Okay. Inverse of chip ratio. Or we can also call it chip reduction factor. Right. Chip reduction. Chip reduction factor. Right. Chip reduction. Chip compression. Chip compression ratio. Compress greater than, right? This is greater than 1. So I hope you understand this class well. In tomorrow class, we are going to solve some, revise your previous session that you can solve the numerical in the next upcoming class, right? So thank you very much for this.